Hello each and everyone. Welcome to ANAMIKA'S EDUSPACE. Today in this video I welcome all the class 7 DAV School students, and today in this video we are going to study about the chapter 6, all the question and answers of the chapter motion and time. So let's begin, and if you're new to my channel, make sure that you subscribe to ANAMIKA'S EDUSPACE for more question answer videos like this. D. So here we are going to first do the short answer questions. Okay. So these are your short answer questions. Question number 1. A boy walks to his school with a constant speed of 4 km per hour and reaches there in 30 minutes. Find the distance of the school from his house. Answer. We know that speed equals to what? Speed equals to distance by time. Clear, students? So how can we calculate the speed? This is a formula which is given in a book, that is speed equals to distance divided by time. Clear? Next, so we can write like this. If speed equals to distance by time, then time will be multiplied with speed. Okay, and we can write distance equals to speed into time. Now this one is a cross multiplication method. Clear? Next, given speed, what it is given? It is given 4 km per hour. Okay, and the time is 30 minutes, that is 0.5 hour. Clear? Now, therefore, the distance of the school from his house equals to what it will be. I have converted the minutes into hour, as you can see, right? Now, the distance will be speed into time, right? Speed is 4, okay? And the time is 0.5. That is half an hour, okay? 1 by 2. Okay, so we will write 4 into 1 by 2. That is 4 will be cancelled by 2 and we will get 2 kilometer. Okay, so what was the distance of the school from his house? It would be 2 kilometers. Clear, students? Question number 2. The distance between two stations is 216 kilometer. A bus takes 4 hours to cover this distance. Calculate the average speed of the bus in kilometer per hour. Answer. Distance is given, that is 216 kilometer. We all know, right? Next, time taken is already given, that is 4 hours. So we learned that speed equals to distance divided by time. So when we will calculate the average speed, then we will say that total distance covered by total time taken. So that will be 216 divided by 4, and the correct answer will be 54 kilometer per hour. Clear, students? So this is the answer. Next question. Two cars A and B starting at the time from the same point are moving with average speed of 40 kilometers per hour and 50 kilometers per hour respectively. In the same direction it is moving. Okay. Now find how far the car B from car A after 3 hours. Okay, so the time is given, and what is given? Average speed is given, and what we have to calculate now? We have to calculate the distance traveled. Okay, we have to calculate the distance from car A to car B. Clear? What is the distance between these two cars? So answer, therefore the distance covered by car A. So what is the distance covered by car A? Let us see. So the distance covered by car A is 40 into 3, because time is 3 hours and the speed is 40. So 40 into 3, the distance will be 120 kilometer. Clear? Similarly, average speed is already given 40 kilometer and the time taken was given 3 hours. Okay. Now we will calculate for car B. Okay. So for car B, the average speed is 50 kilometer per hour and the time is given 3 hours. So the distance would be speed into time, that is 50 into 3 will be 150 kilometer. Clear? So now we will find the difference between car A and car B. Okay, then only we will get the net distance or the net distance between the car A and car B. Clear? So that's why to find out the net distance between the car A and car B, we have to subtract the distance of car B from car A. Okay, so 150 minus 120, which would be 30 kilometer. Clear? So this would be the answer. So therefore, car B is 30 kilometer away from car A after 3 hours. Okay. Next question. A car moves with a speed of 40 kilometer per hour for 15 minutes and with a speed of 60 kilometer per hour for next 15 minutes. Find the total distance covered by the car in these 30 minutes. So let's begin. Answer. Distance covered in first 15 minutes would be, what is the distance covered? We already studied distance equals to speed into time. So what is the speed given? 40 kilometer. And what is the time given? 15 minutes. So as the speed is in hour, we will also convert the minutes or the 15 minutes into hour. Okay. So 1 hour equals to 60 minutes. Clear? So if we have to make out 1 minute from this equation, then 1 minute equals to 1 by 60 hour. So 15 minutes equals to 15 by 60 hour. Clear? Which would come 1 by 4 because 15 fours are 60. So this would cancel and it would become 1 by 4. Okay. So let's see. So it would be 40 into 1 by 4. Right, like this, 40 into 1 by 4. Now 4 would cancel the 40 and it would come 10 kilometers. So the correct answer for this would be 10 kilometers. Next, the distance covered in the next 15 minutes, what it would be, like 60 kilometer per hour into 15. So again, it would be 15 will be converted into 1 by 4, right? Because it is getting converted into hour. Okay, so 60 into 1 by 4 equals to 15 kilometers. Now the total distance covered would be 10 plus 15 equals to 25 kilometers. Clear, students? Question number 5. Define the term periodic motion. Give 2 examples of the periodic motions that can be used to measure the time. Answer. Periodic motion is defined as the motion which repeats itself after a regular interval of time. Okay? And the examples will be motion of the hands of a clock, because every time the clock repeats its motion, if the hour hand is in this side and the minute hand this side, then every time the minute hand is moving, every regular interval it is moving 1 minute, every regular interval it is repeating its movement, it is repeating its motion. So that's why the motion of the hands of a clock. Next, the motion of the moon is always revolving around the earth. That's why the motion of the moon around the earth. Clear? So these are the examples of periodic motion. Clear, students? Question number 6. Distinguish between uniform motion and non-uniform motion. Give one example of each. Answer. Uniform motion. Okay? And non-uniform motion. So what is uniform motion? The object is said to be in the uniform motion when it moves along a straight path. Okay, and covers equal distances in equal intervals of time. So if I take a graph to make you understand, so uniform motion will be like this. In 2 hours it will travel 2 kilometers, then again in 4 hours it is traveling 4 kilometers, then again in 6 hours it is traveling 6 kilometers. So like this it will always move in constant equal distances, equal intervals. Okay, so these are known as uniform motion. Now the body along a straight path covering equal distances in equal intervals of time is known as uniform body. Next is non-uniform motion. So when an object moving along a straight path covers unequal distances in equal intervals of time, does not move, or it can be does not move along a straight path, in its motion is known as non-uniform motion. Non-uniform means in 2 minutes it is moving 2 kilometers, then at 4 minutes it is moving 50 kilometers. So this is non-uniform, right? Here the difference is 2, here the difference is much more than 2. So it is not uniform. Motion of a free falling object is a non-uniform motion because it is traveling and it is freely falling. That's why it is traveling at irregular intervals of time. Clear? Next. Question number 7. Draw the shape of the distance time graph for a man who is waiting for a bus standing at one point on the bus stand. Okay. So as the man is standing at one point on the bus stand and waiting for the bus, so the path of the man would be like this. So if you draw, then you have to draw it like this. Okay. So this will be distance covered and this will be time. Clear? So you have to plot distance on the x-axis and time on the y-axis. And the man is constantly standing in a single place. So there is no change of time and no change of distances. Clear? So this is the graph number A. And the next one, that is a man working on the label straight and narrow the road with a constant speed. So when there is a constant speed, then there is a uniform motion. So the graph would be like this. If the man is standing here, man will move with uniform motion. So this is y, this is x. Again, this one will be distance covered, this one will be time taken, right? And you can just plot it because it is traveling equal intervals of time. See, it is traveling equal intervals of time. From this diagram you can see. So this will be the two graph. This will be graph A, whereas this will be graph B. Clear? Next. Question 1. A farmer moves along the boundary of a rectangular field ABCD as shown in the figure. He takes 4 minutes to travel across each side. Is the motion of the farmer uniform or non-uniform? Find his average speed over one complete round of the field. Now let us see this diagram. We have got a rectangle, okay, which is named as A, B, C, D, okay, and this is 80, and then this is also 80 meter, this is 40 meter, and this is 40 meter. Clear? Now let us see the answer. The motion of the farmer is non-uniform motion. Why it is non-uniform? Because once it is moving 80 meter and then again 40, then again 80, then again 40. So it is not constant. It is always changing. Okay. The distance is always changing. And he covers unequal distances in the equal intervals of time. So the distance is totally unequal. Sometimes 40, sometimes 80. Clear? So that's why average speed of the farmer would be total distance covered by total time taken. So what is the total distance? You have to add 80 plus 80 equals to 160, right? And 40 plus 40 equals to 80. Now we have to add 160 plus 80 and it would give you 240. Okay, so the total distance will be 240. Total time, how much? 4 minutes to travel each side. So 40 meters in 4 minutes, 80 meters also in 4 minutes, 40 meters again in 4 minutes, and 80 meters again in 4 minutes. So 4 plus 4 plus 4 plus 4, how much it is? 16. So total time will be 16 minutes. And again we will convert the 16 minutes into seconds. By how? 16, right? 1 minute equals to 60 seconds. Okay, and why we are converting this? Because we want to change it in standard unit, that is standard international unit, which is accepted by each and everyone worldwide, right? So that's why 16 into 60 would be 960 seconds. Clear, students? 240 meter divided by 960 seconds would be 1 by 4 meter per second. Okay, and if we convert 1 by 4 into decimal, then it would be 0.25 meter per second. So this is the answer. Clear, students? Next question. During rainy season, Shivam noted that the thundering sound of the clouds was heard 6 seconds after the lightning was seen by him. If the speed of the air is 340 meters per second, find the distance of the point where the thundering sound was produced. Okay. Now answer. Speed of the sound is given as 340 meter per second. Clear? Now time taken how much? 6 seconds. Okay. So speed and time is given. What we have to find? We have to find the distance. So speed into time equals to distance. Okay. So distance would be 340 meter per second into 6 equals to how much? Let us see. Yes, 2040 meter. Okay. This distance would be 2.04 kilometers. Okay. Meters has been changed into kilometer. How it has been changed? Because 1 kilometer equals to 1000 meters. Okay. So 1 meter equals to 1 by 1000 kilometers. So 2040 meters equals to 2040 by 1000 kilometers. And as 1000 is there, so where would be the point? The point would be from the right side. We will count 3-digit places and we will put the point. Okay. So that's why 2.04 kilometers. Clear, students? Next, question number 3. How can we make a simple pendulum? Next question is, a simple pendulum takes 10 seconds, okay, to complete 5 oscillations. Find the time period of this pendulum. Answer. A simple pendulum can be made by a metal ball which is attached to a string or thread that is fixed rigidly at one end. Clear? Next, number of complete oscillation it is giving is 5. Okay? And time is given, right? Then period of the pendulum would be 10 by 5 because it is taking total 10 time, and how many oscillation it is giving? Oscillation is 5. Okay? So per oscillation would be 2 seconds. Clear? It is taking total time as 10 seconds and it is moving 5 times. So one oscillation is taking how much time? So one oscillation is taking time of 2 seconds. Clear, students? Next, question number 4. Carefully examine the data which is given below for the motion of two different objects, that is A and B. State whether the motion of these two objects is uniform or non-uniform. Now the table is given to us, that is 7 a.m., 7:30, 7:45, 8 a.m., 8:15 and 8:30. Total distance covered in meters is given. Okay, and total distance covered by B in meters is given. So at 7 a.m. A covered 0 kilometer distance, okay, whereas B also covered 0 kilometer distance. Then at 7:30 A covered 20, B 10. 7:45 A 30 and B 24. Then again at that is 8 a.m. A 40 and B 35. Then at 8:15 A 50 and B 38. Then at 8:30 A 60 and B 43. Okay. Now let's see the answer. Object A is uniform motion as it covered equal distances and equal number of times. So yes, that's why here all the differences were same, that is 10, 10, 10. Here all the distances are unequal, that is sometimes 10, sometimes 20, sometimes 18, sometimes 14 also. Okay, so A would be uniform motion and B would be non-uniform motion. Clear, students? Next question. Question number 5. Observe the graph which is given below. From the graph, find out the value of the distances of P and Q and value of the time R in seconds. Okay, answer. So this was the distance or the time which is given. Okay, and let us see the answer now. The value of the P would be 3 and the value of the Q would be 12. The value of the R would be 12 seconds. Okay, why? Because why the value of the P will be 3? Because, so here we can see a graph which is given to us. Okay. And how the graph looks? The graph looks almost like this, which you can find in your book. Okay. Here 3 and 4 is plotted. Then again here what is plotted? 6 is plotted and 8 is plotted. Okay. So from here we can find it out that when there is time 4, okay, because this is the time and this is the distance covered. So when there is time 4, it is traveling 3. Okay. Similarly, from the graph, you will also find Q, okay, where there will be time 16. So the Q will be traveling 12 meter. Clear, students? So like this, you can see the graph which is already present on your book and you can write the answer by seeing the graph. Clear? Thank you for watching this video and I hope that you like this video. If you like this video, then do subscribe to our amazing channel ANAMIKA'S EDUSPACE. Also, you can follow us on FB and Insta as well. The link of the two are already given in the description below. The other videos are also given in the description below. The previous videos are also given in the description below. So make sure that you watch all the videos and write all the question and answers, and all the best for your exam, guys. And do visit this channel again and again. Goodbye, take care, and subscribe to our channel, and don't forget to turn on the bell icon so that you can receive the notification whenever I am live.